Hello friends, in today's lecture we are going to do some work on some discrete time signals. So the first one is your unit step, and in terms of the equation it will be written as 1 for n greater than equals to 0 and 0 for the remaining points. The difference will be more in the form of the way you are going to sketch it. So if I sketch it, then it will be this is the time axis, and if I say it as un, then it will be un will be and so on. This is the way you will plot it. 0 1 2 3 4 and so on, means that it keeps on going up to infinite for all the points which are greater than equals to 0. So this is the first unit step signal. If you want to do it for u of minus n, then it will be u of minus n will be 1 for n less than equals to 0 and 0 else. So if you sketch it, then it will be n u of minus n, and these are points -1, -2, -3 and so on. So you can say that between 2 points, means like 0 and 1, -1 here and 0 and 1 here, the signal is discontinuous. So the signal will exist at discrete points only. And what are those discrete points? They must be integer also, so they are always 0 1 2 3 4, or on the negative side they will be 0 -1 -2 -3 and so on. So if we do the unit step function for something like this, that u of n minus n naught, where n naught is a constant, then it will be 1 for n greater than equals to n naught and 0 else. So if we sketch it, so the sketch will be of this form. If I consider that n naught is a positive number, then sketch will be something like this. N naught, the next point will then be n naught plus 1, n naught plus 2 and so on, and the amplitude here is 1 and n minus n naught. So this point is 0 and this is n on time axis, because in discrete time domain we denote time by n. So this is the representation of n is shifted format of unit step function in discrete time domain. For instance, just take an example. Suppose we have u of n minus 2, then it will be 1 for n greater than equals to 2 and 0 else. And if we have to sketch it, I'm giving you more examples so that you can have a better understanding about it. So n u n minus 2, and it will be 2, 3, 4, 5, 6 and so on, and the amplitude is 1. This point is 1, or you can say, if you want to represent 1 also, the 1 is 0, or if you want to represent 0, it's 0, it's minus 1 and so on. So for all these points, the amplitude of the signal is 0. Sorry, excuse me. In a similar way, you can do for the signal defined for negative side for unit step. You can look my video in which I explained the negative sided signal, unit step signal for continuous time domain. The way of calculating it or the finding it from which points you will start is same. The only difference is that you have to define the discrete time signals at discrete points only, so they will not be continuous. So for instance, for any signal, suppose it is written as minus n plus n naught. So as I told you in my continuous time signal video, that this minus n plus n naught will be placed in front of greater than equals to 0. So then you can say n is less than n naught. So if you plot it, and my n naught is a positive number, so if you plot it, it will be for n naught as positive. If you plot it, it will be starting from somewhere n naught and so on. 1, sorry, this is axis. So for all the points which are less than n naught, similar signal when n naught is negative. When n naught is negative, so n naught will be somewhere here. So it will be n naught, it will be n naught plus 1, it will be n naught plus 2. So in this way the plot will go this side. So this point will be 0. This is, remember this, that this point is n naught, and this, the next point on the left hand side is 1 point less than. And in negative, if it this, suppose let's say n naught is minus 2, then the next point will be minus 3, minus 4 and so on the negative side. So in this way you will do the unit step signal. The next signal is your The next important signal which we are going to use is unit impulse signal or function, and it is defined as delta n 1 for n equals to 0 and 0 else. The one important difference between discrete time domain impulse function and continuous time domain impulse function is that this function can be derived from unit step function. So if you use un minus u of n minus 1, so if you subtract these two, then you will be easily able to find the unit impulse function. I'll show you how you do it. So let's plot both of them, un and un minus 1. So un is plotted like this. So if I have to plot on n, this is un, let's say this is u of n minus 1. The point 0 is same for them. So un means that you start your signal from 0, means n greater than equals to 0. Same, these bits are same. So this is 0, this is 1, this is 2, 3, 4, 5 and so on. Un minus 1 means that n greater than equals to 1. This means n greater than equals to 0. So the first point in un is 0. The first point in this one is 1. So it will be please mind my drawing, I'm not very good in drawing. So the spacing between any of these two are equal, it's 1. So this is 1, 2, 3, 4, 5. So if you subtract these two, then you can easily see the signal which will remain will be delta n. And why it's delta n? The only point where you will have remaining 1 will be at n equals to 0. So in this way you can find out any of them. So if you say un, if you want to find out, if you will subtract these two, then you can see that it will be equals to delta n minus 1. If you will subtract then you can get, and so on. So next important signal which we are going to use is complex exponential signal. Complex exponential signal. So you can say x of n equals to your e raised to the power j omega naught n. So if you know that, you can write it equals to j sine omega naught. Important thing which you need to remember about this signal is that mode of x of n is equals to 1. And omega naught is its frequency. So omega naught is equals to 2 pi upon N naught, where N naught is time period of the sorry, it's time period of the signal. So these are the some important signals which we need to know in this discrete time domain. So if you have any queries, any questions, please put it in the comment box. Please like, share, subscribe my channel. Thank you.